I'm Bryce Brown.
Two-stage ditch design. What are the two stages?
Two stages is, you got a first stage, which mainly is hold your water and everything. Basically, then the second stage is like another ditch inside of it, or on top of that, really. And what it allows it to do is, on that second stage, when the water comes up, it goes across the tables, and it slows the water down so you don't have as much erosion.
Okay, so who was the project sponsor, and what is the real problem we're trying to solve?
The project sponsor was the NRCS, which is the Natural Resource Conservation Service. The project was actually, there's a old 18-inch existing tile line that's running through what is now a grass waterway at the moment. And what has happened is that tile line has deteriorated and is starting to fall apart. So they decided they wanted to go with a two-stage ditch and tear out the tile line. So, yeah.
Emily, I see here you're talking about the culvert under 900N. Is that like 900 newtons, a measure of force? What are you talking about here?
900 north is the road.
A road. Oh, gotcha. So explain, Bryce gave us an overview of what it is, but are there equations that describe this phenomenon? What's going on here?
To design for open channel flow, you need to use Manning's equation and design for the peak flows of the area.
Like Peyton Manning?
Not quite Peyton Manning, but close.
So this Manning's equation, I see some equations up here, so it helps you calculate how fast will water flow.
Yes, Manning's equation.
What happens if the water goes too fast?
If the water goes too fast, you will have bank erosion and you will have flooding.
And what if the water goes too slowly?
If the water goes too slowly, you'll have standing water and you won't have a channel.
So we've got this Manning's equation that can help you calculate flow of water, speed, and you said you don't want it too fast, you don't want it too slow. How did you settle on the geometry of your two-stage ditch?
To settle on the geometry of the two-stage ditch, we had a design standard provided to us by the NRCS. Our design standard said that the ditch needed to be under 2 feet per second, but we had too large of a ditch and our flow rate was still above 2 feet per second, so we had to change the geometry to match 2 feet per second.
So what are these drawings of here, right?
Okay. Basically, these drawings are, this one right here is the design of the channel that we came up with. And then down here is one of the existing cross sections of the channel. And then the purple line you see here is this channel overlaid with what it'll look like with the new channel. Basically, this is just an exaggerated view then of the cross section.
So we're really talking about a replacement for tile drainage.
Yes.
With relatively minimal excavation cost, or what?
No, not really.
Extensive excavation.
Yes.
but an environmentally sustainable solution.
Right.